All right, let's dive right into this explainer and explore the incredible complexity of today's electric grid and exactly how we go about measuring its sustainability. We flip a switch and the lights come on. It's simple, right? But behind that everyday action is a massive, highly regulated industry that is facing some intense scrutiny over its environmental and social impacts. So, you might be wondering, with such a chaotic mix of traditional and renewable sources feeding our homes and businesses, how do you even begin to keep an accurate score of those impacts? It's a massive challenge. You can't just slap a green label on a giant utility company and call it a day. Investors, regulators, and everyday consumers, we all need hard, comparable data. Well, the answer actually lies in the SASB standards framework, which is now part of the IFRS Foundation. This incredibly detailed document provides the strict accounting metrics that electric utilities and power generators absolutely must use to report their impacts. Think of it as the ultimate scorecard for the power sector. It takes these vague sustainability goals and transforms them into rigid, quantifiable data. Here is our roadmap for this explainer. We'll start with the modern energy mix, then look at tracking the carbon footprint, water use and waste, the social cost of power, resiliency and the grid, and finally, measuring a sustainable future. Starting us off with Section 1, the modern energy mix, the baseline of power generation. Under these standards, utilities have to report their total electricity generated, but they can't just give us one massive number. They're required to break it down into an exact percentage mix of major energy sources. Because, let's face it, we're looking at a deeply diverse energy landscape today. On one hand, you have traditional power generation from fossil fuels, like coal, natural gas, and petroleum. Then, you have nuclear energy. And alongside all of those, we're seeing the rapidly growing integration of renewables, things like hydropower, solar, and wind. Analyzing this specific mix is absolutely crucial because every single source carries its own distinct risks. A grid heavily reliant on coal faces entirely different regulatory and environmental hurdles than one heavily invested in solar and wind. This breakdown provides the critical baseline for literally all the sustainability metrics that follow. Moving right along to Section 2, tracking the carbon footprint, focusing on measuring Scope 1 emissions. To figure out the true environmental reality of this diverse energy mix, we've got to start with the heavy hitters. Electricity generation represents the single largest source of greenhouse gas emissions in the world. So, to keep the reporting completely standardized across the entire industry, emissions of 7 major greenhouse gases, like carbon dioxide, methane, and nitrous oxide, must be consolidated. They are mathematically converted into metric tons of carbon dioxide equivalents, and this is based on a strict 100-year time horizon for global warming potential. This ensures we are comparing apples to apples, no matter what invisible gas is actually leaving the smokestack. But it's not just about the total volume of those emissions, it's really about the financial risk attached to them. Utilities must separately track the percentage of their Scope 1 emissions that are covered by strict limiting regulations. Think cap-and-trade schemes or carbon taxes that actually cost the company money out of pocket versus emissions that only require mandatory reporting with no hard limits. This gives investors a crystal clear picture of how much of a utility's carbon footprint represents an immediate financial liability. Next up is Section 3, water use and waste. We're looking at the hidden costs of thermoelectric cooling. Moving beyond the air, let's talk about the ground. Power generation requires massive physical resources. Traditional thermoelectric power plants, like your coal, nuclear, and natural gas facilities, use absolutely staggering quantities of water for cooling. As water supplies tighten up globally, this becomes a massive operational risk. The SASB standard requires utilities to analyze their operations and strictly report the percentage of their water withdrawal and consumption specifically in these highly water-stressed regions. If a utility relies heavily on a plant in an extremely high-stressed area, that plant might literally be forced to reduce output during a drought, which directly impacts the grid and the bottom line. And then, of course, there's the physical waste. For utilities in our energy mix that still rely heavily on coal, they are generating millions of tons of coal ash, which contains heavy metals. Utilities must disclose exactly what percentage of these coal combustion products is beneficially recycled, like being sold off to make concrete or wallboard, versus what is just disposed of as hazardous waste. Managing this effectively can actually turn a massive liability into a solid revenue opportunity. This brings us to Section 4, the social cost of power, specifically looking at affordability and worker safety. A truly sustainable grid isn't just about being green, right? It has to serve the human element. The standard demands that utilities translate their technical data into real human terms. First, they report the average retail rate to see how costs are trending for everyday folks. But more importantly, They have to track how many residential customers are actually disconnected for non-payment, and what percentage of those people are successfully reconnected within 30 days. This measures whether utilities are keeping the lights on for vulnerable households in tough economic conditions, which is absolutely crucial for maintaining public trust. And hey, we absolutely cannot forget the people actively building and maintaining this dangerous infrastructure. These workers face extreme heights, heavy machinery, and severe electrocution risks every single day. Safety is tracked meticulously against a 200,000-hour baseline. To put that into perspective, that represents 100 full-time workers putting in a year's worth of hours. Utilities use this exact formula to calculate and report their total recordable incident rates and fatality rates for both their direct employees and their contractors. Okay, Section 5, Resiliency and the Grid, and how we are preparing for the future. As we fold more of those intermittent renewables like wind and solar into our energy mix, we really have to talk about withstanding modern threats. When extreme weather hits or equipment fails, a sustainable utility needs to bounce back fast. Metrics like SAID hold utilities accountable by measuring exactly how many minutes you, the average customer, are left sitting in the dark during a reporting period. They even have to calculate this factoring in major event days, like severe storms, to show their true baseline resilience. To combat those frustrating outages and manage this incredibly complex modern energy mix, the framework focuses heavily on the deployment of the smart grid. This isn't just about replacing old wires on a pole. It's about using advanced digital technology to monitor power transport, integrate diverse energy sources efficiently, and provide real resiliency against disturbances and natural disasters. And utilities can't just say they like the idea of smart grids. They must measure the exact percentage of their total electric load that is actually served by this advanced technology. By tracking this specific data point, we can clearly see a utility's actual progress in upgrading our legacy infrastructure, rather than just listening to their future promises. Finally, Section 6, Measuring a Sustainable Future, taking a look at the big picture. Let's pull all these distinct parts of the energy mix together. The SASB framework really ensures nothing is left in the dark here. If a utility has nuclear power in its mix, it must disclose the results of independent safety reviews. As our grid gets smarter, it inevitably becomes a target, so utilities must report any incidents of non-compliance with cybersecurity standards. They even have to calculate the exact megawatt hours of electricity their customers saved through utility-sponsored efficiency programs. Every single megawatt, every risk, and every emission goes right on the ledger. So these standards give us the ultimate scorecard for the modern energy mix, from the sheer volume of water needed to cool a nuclear reactor to the safety of the line worker restoring your power after a massive storm. The data is all there. But it leaves us with one really vital question. Is meticulously tracking and disclosing all this data actually enough to force the massive innovation we need for tomorrow? Or is it really just step one? Definitely something to think about the next time you flip a switch.